Hello everyone and welcome back to the Kohi Game Engine series. Today we're actually going to resolve a couple of issues architecturally that we sort of have going on, and resolve some to-dos that I've got in place, and add some metrics in, and just kind of handle a little bit of sort of miscellaneous stuff that has been pushed to the side for quite some time. And so what we're going to be doing primarily today is we are going to be shifting the responsibility of a lot of the temporary application stuff that we're sort of using in our testbed to actually be in the testbed. So what I mean by this is if we go into the application.c and we examine this, we've got a whole bunch of stuff in here like to-do temp stuff. Below our systems, we have a whole bunch of temporary things here with meshes being loaded and sort of all this stuff that has been landing in our application over time. And this obviously is not where this stuff belongs. Where this stuff should be happening is it should all be managed and stored by the ultimate consuming application of the engine, not in the engine itself. Now, when we initially stood this up, we didn't really have one of those, and a lot of this stuff wasn't really exposed. And so we've gone ahead and done a lot of that work, and so now we can actually start to leverage that and begin actually using the application in the way that it was meant to be used. And so we're actually going to be removing a lot of this temporary code out of the application C file and moving it to our testbed. And this is another step that is going to be necessary for us to eventually bootstrap our editor, because our editor is going to have a different configuration of its own. And when I say configuration, we are basically going to be creating an application configuration, which we already kind of have scaffolded, but we're going to be using that a lot more going forward to actually tell the engine, hey, this is our application, and these are the things that we need to be set up for it to actually run the way that we expect it to be run. Anyway, so with all that aside, there are a couple of things that I want to go ahead and knock out first before we jump into the meat and potatoes of this. So the first thing I'm going to do is open the logger.c, and I'm going to remove our temporary code here. So we have this test stuff that happens every time we launch the engine. That's been in there for a long time, since the live stream actually. And so I'm just going to remove that because we really don't need to do that anymore. I'm also going to remove this to-do here to create the log file, because that is actually happening up here. So that to-do is no longer necessary as well. Okay, so that is it for the logger C file. So I guess the next thing that we'll go ahead and do is we'll go ahead and create our metrics file. And so what I mean by metrics is if we actually clean and build the application real quick, and we'll go ahead and run it, we actually have some data that's being printed. You know what? I actually have the unit tests running. Which actually, it looks like we're actually failing some of those unit tests, so we probably ought to come back and do that as well. But let me change this from launch unit test to launch testbed. Let's try that again. Okay, so if we actually launch the application, we see that we've got some metrics already happening down here, right? So we're keeping track of the FPS and as well as the frame time. And so I actually want to shift the responsibility of this out of the application itself and have a self-contained system, if you will, for metrics. And so that's what we're going to go ahead and handle now. So let me actually just get rid of this console, all of them. All right, and the first thing I'm going to do is we're going to go ahead and create this in core. So I'm going to create a new file, and we're going to call this metrics.h. And the metrics.h is going to have a number of facilities available in it. But we're going to keep this short and sweet in the beginning. So we're going to have an initialize, which is basically to set up some initial state that we actually need and require to the hood. We're going to have a update call, so this is going to be called every single frame. Then we have a method to retrieve the current average, the running average frames per second. So we're going to keep a running average just like we're doing in the application, except it's going to be sort of wrapped up in this instead. Then we're also going to have a separate call for the frame time, so we can get those things individually. And then we're also going to have a function that gets both and just sets those things in the pointers that are provided here. So not a whole heck of a lot going on there, but it gives us a little bit of separation of responsibility. Okay, so we're going to go ahead and create a metrics.c, and we're going to go ahead and implement this. And this is actually all code that we've seen before, so I'm not really going to go into in-depth on any of this, okay? So the first thing that we have is obviously our memory. We have a metrics state, which has all of our frame counter, our frames counts, accumulators, things of that nature. Obviously, it has a state pointer. Our initialize, like a lot of other systems, goes ahead and sets up that state pointer. Our update, of course, checks to make sure that exists, calculates the average frame time in milliseconds, and then calculates frames per second once we've accumulated 1 second. So basically just every second it updates. And then we have a method to retrieve the FPS. So this just does a quick sanity check to make sure the system's been initialized, returns 0 otherwise. That just keeps us from crashing. The frame time is the same thing. It just does a quick check to keep us from crashing if it's not been initialized, and then returns the millisecond average. Obviously, the metrics frame here does both, so it just makes sure that that there is a state pointer, sets both those things to 0 if we are not initialized, and returns. Otherwise, it sets those to the FPS and millisecond average accordingly. Okay, and that is all there is to the metric system for now. We are going to be adding a lot more to this through the series as we continue on, just to keep track of multiple various things. But for now, that's all that's actually going to take place. Okay, so I think the next thing that we're going to do is I'm going to make some changes to some of our types. So our render types is going to need the first set of updates. So I'm actually going to look for render view config, and right here, after we actually declare render view packet, we are going to declare forward declare another structure, which is linear allocator, because we are going to need a linear allocator for each frame. And so we're actually going to wind up calling this a frame allocator. And basically what that means is we're always going to have the need to perform dynamic allocations every single frame. But doing that through the dynamic allocator is not always going to be the fastest way to do it. Because a linear allocator doesn't have to worry about freeze. It doesn't have to track anything. It just basically moves a pointer along as you allocate things. It's super fast to get those allocations. And so for things like building lists and whatnot, render lists, things like that, we actually need something that basically runs or is available every frame. And so a linear allocator fits that bill perfectly, because we can just perform all of our allocations per frame, and then at the end of the frame, we just clear the allocator, which throws all that stuff away, because we just need to go ahead and do the same thing on the next frame. And so that is why we are adding a linear allocator here. So that's the forward declaration of that. And then if we come down a little bit further into our render view, we are going to be adding to the on-build packet the linear allocator itself. So we're going to be passing in right after self, we are going to pass in a pointer to a frame allocator. So that's a linear allocator that we're just going to call frame allocator. And we'll stand that up here in a bit. So let's go ahead and update the comment here. Just a frame allocator, use this frame when building the packet. So this is a primary example of what we're going to need that for. And one more minor change that we're going to need to do is I'm going to look for oops. I'm going to look for Skybox packet data because we actually need to add something to this. So right now we have this sort of Skybox here. And this is we're going to be changing it up a little bit how this works. So we're going to forward declare this now. So we're going to say struct Skybox, and we're going to say struct Skybox pointer, right? And this is because we are actually going to wind up moving the definition of a Skybox to its sort of own compilation unit. And so one of the changes that we're going to perform to our linear our render types is going to require that we actually move that. So we're going to go ahead and make that change here. Okay, so that's it, at least for the renderer types there. I think probably the next thing to do is going to be to actually go through the views and update them to match and use this new linear allocator. And so what we're going to do is we'll go to, I think the first one we'll start with is probably just going to be the render view pick. And right at the top in the includes, we'll put this after transform. We're going to go ahead and use our memory linear allocator. And obviously to match the interface that we have set up, we are going to go to the onBuild packet. And right after self, we are going to put in a pointer to a frame allocator, or a linear allocator rather. And instead of, let's see, our extended data, instead of our data that's being passed through, we're going to treat this a little bit differently. Instead of using that directly, we are going to call our linear allocator and allocate some memory for that, right? And that's just going to be the pick packet data that we're going to use for that, all right? And the reason that we're going to do that is because we are going to come down here, and at the end of all this stuff, we are going to take a copy of the packet data instead of using it directly. And that's going to allow us to have, or to not have to worry about the data being fed over and the life cycle of that data once it's been fed to this. So once the packet has been generated, we take a copy of that data, and it no longer matters what happens to the data that was passed in to this function. After that, we don't have to worry about keeping it anymore. And so that's a definite required change that we want to make. So that's the C file. Obviously, this means that we'll have to go to the H file as well. In fact, I'm just going to copy this guy and go to the H file. Oops. Because that doesn't match anymore, I'm going to put that here and then forward declare linear allocator here. All right. And that is going to sort that view for us. And so obviously that means that I'm going to have to do the same thing for the other views. So I'm going to go ahead and do the H files first. So on build packet right here. And then I'm going to take this and forward declare here. And copy this again. Go to the H file here. And here. All right, forward declare, and last one. Paste that in. Go here. Paste that in. And obviously that means that I'll need to go to the C files and do the same thing. So I'll just go ahead to those. So we have our build packet here. So I'll just paste the function definitions first. That way I don't have to jump around quite as much with all the copy pasta going on. So this one needs right here. Okay. And as far as the guess we'll do the Skybox one next. We'll go to the top here, right below transform. We'll go ahead and include resources skybox.h. This is a hint as to what we're doing with the skyboxes. We are going to be creating a separate resource type for that. Now, I should point out that the render view skybox does not actually do anything with the linear allocator for now, so I'm not going to bother including that. But when we go ahead and actually use it, we may need to include it. But for now, I don't need to. So let's go to the UI, and we'll go all the way to the top. Right after transform, we'll put in our linear allocator here, and we'll come down to our on build packet, and we'll just need to basically do the same thing that we did before with the previous view. So right here where we are setting the, where is it? The extended data, there it is. So we can go ahead and do that. So we'll allocate there. And then in this case, we actually don't have to worry about any of this processing first, so we can actually just go ahead and take a copy of it right there. So that is that. And then the world, go to the top here, paste, come back down here. The world, I believe, is, actually, I guess we don't really need to do that in this case. Yeah, I think the world will actually be fine for now. So I'll just go ahead and leave that as is. And that is all of the updates that need to be made for the views. So the next thing we're going to do is resource types.h, and we're going to take our Skybox from here, and we're going to remove it from here because it's actually going to sit in its own file now. So we'll go ahead and clip that out of there. And speaking of the Skybox, we are going to go ahead and create our resource type for that. So under resources, create a new file, call this skybox.h. And I'm actually just going to just slam the entire thing in here at once because it's pretty self-explanatory. There's not really much to go into here. So we have our structure now declared here. We have a create and we have a destroy. The create takes a cube map name and a pointer to put the skybox into, with a boolean to indicate success or failure, and then the destroy is pretty obvious, right? And this is just sort of to allow us to encapsulate this in such a way where we don't have to worry about the application doing all the work because it was and it should not be. So we're going to create a skybox.c now. And again, I'm just going to slam the code in. So this is basically everything that the application was doing previously that we don't need it to actually do. This should all be done in here. And so basically this is responsible for setting up the texture map, going ahead and acquiring the resources, getting the cube texture. And again, this is actually a hard-coded thing here. So this particular name here, Skybox, I'm going to put a to-do. Name is hard-coded, right? Because obviously we want to have that be configurable at some point. But for now, let's just keep it nice and simple. So we're basically sticking with the same properties that we had before, right? We also have a hard-coded shader in here, so we might want to allow configurable shader here, because we might want a fancy shader that does something different. But other than that, we go ahead and acquire the instance resources for the Skybox itself, and we return true. And then basically the Skybox destroy just releases the resources. When we shut down the texture system, it'll go ahead and release all these resources. So I think we'll actually be fine as far as this is concerned. So that is the Skybox. Really not a whole lot to explain there, just really kind of moving it off into its own thing. One more thing that I do need to update is having to do with render views. I forgot to do the actual system. So we need the render view system. We'll do the H first. So we'll come here into the build packet, and right before the data, we'll go ahead and put the frame allocator. And then obviously we'll need a comment for that as well, which I actually have right here. Okay. And then this means obviously that we'll have to go into the C file, which is here, and just pass that on through. So let's see, we have our build packet here. So we're going to insert our new parameter there, insert that there, just pass that through, and we should be good to go on that. So that's the render view system updated. Again, nothing crazy there. Okay, so now we have basically a lot of moving around of code to do. So there's a lot of code that's going to be removed out of the application C file, and a lot of code that's going to be inserted into the game itself. So I think before I do either of those things, I think we're going to update those types first. So I'll go to application.h, and we're going to need to actually include a couple more things here. And this is just temporary because our application config is here, right? But we are actually going to need some configuration for our fonts and our render views. So right here after the application name, we are going to have our font config. So this is going to be the fonts that we want to stand up. Eventually we will find a better way to do this, probably a configuration file that gets loaded up and parsed and then creates this sort of application config thing here. But for right now, this is just how we're going to do it. So we have that, and then we're going to have an array of render view configurations that the application itself, or the consumer of the engine, is going to set up and pass over to the engine. So we've gone ahead and included those things there. And then before we move on to the C file updates of that, I do want to go ahead into game types.h and perform an update here as well. So under our include for our application, we are going to need our linear allocator included here, and we are going to need our render packet forward declared. And so the next thing we're going to do is we're going to come down to our game structure itself, and we're going to add a new function pointer here. And we're going to call this boot. And basically this is a pre-initialization function that happens. And we're going to call this the boot sequence because this is what boots the entire application up and gets things ready to run. And what this is going to do is this is where we're going to gather all the requirements from the application that are required of the engine before we actually start everything up and get everything running. And so this is where we're going to build our actual configuration and eventually parse it once we have a file. Okay, so the next thing that we're going to do is we are going to change our game render to just accept a render packet. And that is basically just because we might need some of the data out of the render packet in the actual game. In fact, we are going to need that. So we're going to just add a comment here so that accepts that. And then we're also going to add another method here. So we have sort of our initialize, our update, our render, a resize handler, but we don't have anything for shutting the game down or releasing our resources. So we need that. So we're going to set up a function pointer for the shutdown of the game. All right, and then finally, in the actual game state itself, we are going to need to add the linear allocator that is our frame allocator. So this is where that is going to be stored. And this is so that both the game and the application can actually get access to this. And so both will need to use it. And so for now, this is kind of where it makes sense to actually put that. And that is about it for that. So now we're actually going to jump into a lot of the changes that we're going to make in the actual application itself. And so the way I'm going to tackle this is we're going to make all the changes to the application itself, or the application C file, and then we will sort of unwind a lot of those changes in the game file itself. So we'll start off with application C. And the first thing that we're going to do is we're going to come all the way to the top, and we're going to get rid of a couple things I know off the bat we're not going to need. So we're not going to need identifier. We're not going to need any of this temporary stuff. So we can get rid of that. We are going to need, though, a couple of other core things which aren't here. So we're going to need our new metrics that we created, and we're going to need our D array. So those are basically the changes that are going to be needed at that level. Now the application state itself, I mentioned that all this to-do temp stuff is going to go. We are finally getting rid of that. So that is all gone. We are just storing application state here now, right? So that's a lot cleaner. And we are going to come back and clean this up too, because this is getting kind of unwieldy whenever we add new systems to this, right? This is definitely not the ideal approach here. And now that we're getting away from all this temporary code, we're actually starting to structure things out. Issues like this are starting to sort of present themselves. Okay, so let's go down a little bit further. So we have a couple of temporary methods here that we're going to get rid of. We have our application on event. We actually do need to keep that one, but these other two, application on key and on resize, these can actually go away. We are not going to be handling those events at this level anymore. We also can get rid of this temp event on debug event. That is going to be going away because we are not going to be handling that anymore here. Oh, you know what? I do actually need my application on resized. I shouldn't have gotten rid of that. I do actually need to keep that. Okay, so the next thing that we're going to do is we'll come down here. Let's see, our application. Right after UUID seed, we are going to initialize our metrics. So we want to get that up and running sort of right away. So we'll go ahead and add that there. Our temp debug models loaded equals false. That is going to go away. Let's see, what other code can we remove? So we need to keep the application quit. The press and release handlers can go away. The resize we are going to keep, and all this other stuff is actually going to go away, including the hover ID change and all that. So we are just going to keep basically application quit and code, or the resize code. And now we're going to come down here a little bit. Let's see. So right after we stand up our renderer, we are going to go ahead and perform the game's boot sequence. So right here, we're going to just say game instance boot. And if that fails for some reason, we'll bleat about it and return out. I think also I'm going to go ahead and take the version here and remove it from up here, and instead put it down here after the boot, because it doesn't really make sense to sort of print that out before we're actually ready for it. So let's put it right here. Okay. So that's that. Next, we are going to go ahead and come down here to the font system. So we have a whole bunch of configuration here for the font system. And that is not the way we want to do it. So we are actually going to get rid of all of this configuration stuff, right? And we are instead going to call font system initialize. Instead of the font sysconfig, we are going to call, we're going to say the address of game instance app config font config, right? And that's going to be what we're actually going to use for that. And let's see, so we have that change there. We're also going to need to make it here. So we're just going to be passing that in from the application config now. So that makes that a lot cleaner. We're probably going to wind up treating some of these other systems that way eventually, but this is a big one that needs to be changed. The next thing that I think we're going to change is the way that these render views come in. So we have these render views that we're loading, and basically we're kind of configuring these things here, and we really shouldn't be. So if we scroll down here, we have all of this that we're doing, right? And really this shouldn't be happening here. So what I'm going to do is I'm actually going to delete all of that because this is already sort of pre-configured, or should be configured for us by the consuming application. So instead, what we're going to do is we're going to load up the render views from the application config, and this just turns into a simple loop. We get the count of views, loop through each one, go ahead and grab a pointer to that, and call render view system create, passing through the view. If we fail one, we bleat about it and boot out, and then we're done. So this is very flexible this way, and it allows the application to determine how it needs to be rendered, and each application is going to have different requirements, so now that's a lot more flexible. Okay, so the next thing is all this to-do temp stuff. So we basically have a whole heck of a lot of code in here. Before we initialize the game, where we're loading up meshes and textures and our Skybox and some UI geometry, UI controls, or at least some precursors to UI controls. And basically all of this crap all the way through up here, we're going to get rid of it. We're going to move all that to the game itself. So again, that massively cleans things up for us. Okay, so the next thing is this average count. We do not need that anymore because that is handled for us by the metrics. We also do not need all of this frame counter stuff. So everything after frame elapsed time, we do not need. Then I'm going to come in here, and right after we do the job system update, we are going to go ahead and update the metrics at this point. So we're basically going to pass in the frame elapsed time that was calculated on the last frame. Then we're going to come down here and where we're calling the game's render routine, basically from there all the way through where we're creating these rotations, we're going to get rid of all that stuff. And I am going to leave this to do here. We actually do need to redo this, but we're probably not going to handle that right now. So for right now, we're just going to create the packet here. However, all this to do read from frame config, where we're sort of making assumptions about how the game needs to be rendered, this is all going to go away. So basically, we're going to take from here all the way down to where we build the packet for the pick feature. We're going to get rid of essentially all of this, right? That whole temp section. So now we're just going to have sort of this packet object that gets created here. We're going to fill out the delta time. And then what we're going to do is we are going to call the game's render routine at this point. And the biggest change here is the fact that we are just passing the address of the packet, giving us a pointer to that, right? So we're creating it here, passing that packet off to the game, and letting it actually build the packet, because it understands how it's supposed to be rendered, so it makes sense that that should be built at that point. So that is that. This also means that, let's see, so we have the draw frame, cleanup packets, yeah, that should stay there. And in fact, this is no longer temporary, so we can just remove that, because that always needs to happen. And then we don't need this anymore because that's being done by our metrics. And I think that's it for the main game loop. So the next bit is basically this temporary code here where we're releasing resources and all that. We are going to, let's see, get rid of everything in this first section. So all that can go. We're going to shut down the event system. We don't need key pressed and key released to be unregistered. We don't need this to be unregistered anymore. So those can go away. What we do need to do, though, is we do need to shut the game down. So we're going to put that here. Before we shut anything else down, we're going to call shutdown on the game. And if we go down here a little bit further, we have our application on event. And we're no longer going to handle this hover ID changed here. That's going to be handled by the application. So we'll get rid of that. And that's really only a temporary thing anyway. So we're probably going to be getting rid of that permanently here shortly. But for now. So the application on key is no longer used. So we're going to get rid of that. The application on resize just needs basically this bit here, this temporary to-do section down here, removed, and that's it. So really we have cut our application C file in like half. It's actually less than half, I think, slightly. So that is cleaned up. And so that is one big chunk. And the only other big chunk we have left, I believe, is the game itself. There actually is one more thing I forgot to do. We need to go to entry.c. I forgot to set up our function pointers. So our game has two new functions. So we need to forward those. So that's our boot and our initialize. So our, we're going to remove initialize from down here and just kind of put it up here. So it's kind of an order that makes sense. So we have our boot rather and our shutdown. Now we haven't actually created these two methods yet. So those don't exist just yet, but we're getting to that. So I guess what makes sense from here is probably to go to the game.h and add a few things here. And this is basically where we're going to be adding a lot of those to-do temp things that we had in our application.c file. We're going to be adding it to our game instead. And incidentally, we're probably going to be renaming the application.c file as something else because it's a little bit confusing because it's not the application. It's sort of the engine, if you will, or the engine main. I haven't really come up with a name for it yet, but we're going to be renaming that to something else here shortly. Probably not in this video, but in the very near future. Anyway. So we have a couple of temporary includes here. So we're including Skybox and UI text because we are creating temporary objects with those things. And then here in our game state, we have all of our stuff is going to be added back. So we have our width, our height, our Skybox, our meshes here, our UI text, and our hovered object ID. The other thing that we're going to have to do is we are going to have to forward declare the packet structure, so the render packet. We are going to declare our game boot, right? And we are going to modify our game render to take in a pointer to a render packet. And then we are going to add game shutdown, so that everything in this entry C is satisfied. All right. So the last bit of this is the implementation in our game.c file. And so a lot of this is exactly the same as it was before, so I'm not really going to go into super detail here. But just bear in mind here, we're starting with 133 lines. This file is about to get a lot bigger. And that's okay, because again, it's just our test bed, right? So not a big deal. So after event, I'm going to include our metrics and our D array, and we're including our metrics on this side too, so that we can get our frames per second and our frame time, because we still want to print those things out. We also are going to need to go ahead and get our renderer front end, so we'll do that. And then we're also going to need to include all of our views. And I'm saying to do temp here because I'd really like to find a better way to sort of handle this without having to call these explicitly, i.e. a configuration file. that would sort of just use the render view system to stand these up. But for now, I've got to include a lot of these things. So we do need our identifier, our transform, Skybox, UI text, all of our sort of temporary stuff that we're using here. I'm going to declare a method called configure render views, which is going to return a Boolean to indicate success. And obviously that's going to take a pointer to the application config. So we're going to basically take all of our render view config and we're going to put it into this application config and set that up that way. So the next thing is we're going to have a couple of event handlers. So I'm actually going to, let me do them one at a time. I was going to put them all at once, but I think they're big enough to warrant doing them separately. So here is our game on event. This is basically just going to handle the hover ID changed event. So not a whole heck of a lot has changed there. We are going to have a separate handler for our debug events, just to kind of keep that separate. If we want for release builds, for example, we could just if-def this out and not have to refactor our code. And then we are also going to have another one to handle our key presses. So we're going to put that here. And of course, that's going to be doing all the same stuff it did in the application. It's just going to be here instead. The next thing that we're going to do is we are going to go ahead and define our boot function. And again, this is going to go above initialize here. And so basically what we're going to do is we are going to output something that says we're booting up our test bed. We are going to go ahead and set up our frame allocator here. And this, I haven't really decided if this is the best place to set it up or not, but it's configurable here. Because the application should have some sort of idea of how much it's going to need for a frame allocator. So for now, it's going to be basically 64 megs. So the next thing we'll do is we'll go ahead and take a pointer to the config. And we will go ahead and configure our fonts. So we're just going to go ahead and paste in all the configuration that we had in our application C here. So it's okay to make these sorts of things in the application layer. It's not okay to make these things in the engine itself, right? So in the actual consuming application, it's okay to make those assumptions. And then finally, we are going to go ahead and configure the render views. And I have a to-do here to read this from file because doing it this way sucks. But we'll go ahead and call our configure render views and obviously check that for success. If we are all good, we go ahead and return true at that point. Our game initialize is also going to grow quite substantially. So we are going to basically, I think, I really don't need to kind of do this separately. So what I'm going to do is right after we've grabbed a pointer to the game state, I'm going to put in all of our temporary code here. And this is all the stuff that's moved directly from the applications.c file, right? So we have our state models loaded. We're creating our UI texts here, our Skybox. We're using our Skybox create that we just created, right? So we're using that now. We have our world meshes. Here's cube meshes, right? We have our car mesh, our sponza mesh, all of our test geometry. And all of that, right? So it's the same stuff that was there. It's just in a different location. And finally, we're going to go ahead and re-register for the events that we need to handle. So after this camera position set, we're going to go ahead and register for the event code debugs 0 and 1, as well as the non-temporary ones, which are going to be, well, I guess this hover ID change is kind of temporary. So let's move it up there. And then the event key code pressed and released. So we'll go ahead and handle those. So now those are hooked up. And so we have our initialize done. The next thing we're going to put in here is before actually our game update is we are going to define our shutdown. And the shutdown is going to handle basically all the stuff that came after the game loop previously. So that's going to be destroying the Skybox, destroying the UI text, unregistering from the events, which it looks like I missed this one. So let me put that here, unregister, and I guess it doesn't really matter. This should probably be a game instance on all of these, actually. These are all zeros. That should probably be game instance, just so they actually get unregistered properly. And next, we'll go ahead and update our game update. So basically what we're going to do is at the very beginning of every frame, we are going to reset our frame allocator. And so that's basically just going to be a call to linear allocator free all, passing our frame allocator. So it's wiped clean and ready for the next frame. So we do that at the beginning of the frame. And then after we do, let's see, let's pass all of our game's logic here. Let's see. I guess probably, yeah, let's do it after this end temp. We're actually going to put in all the logic that was in place in the application C file. We'll put that here as well. So this is actually sort of our game logic, if you will. So this is all of our rotations that were happening, all of the preparation for the text being printed to the screen, getting the getting the FPS and the frame time here with the metrics frame call. All of those things all moved over into our game update, right? It just makes sense for that to be here. All right, next, our game render hasn't really done anything up to this point, but that is about to change. So we are going to add a render packet to it. And we'll go ahead and grab a pointer to the game state. All right. And we're going to put in some temporary code here. And this is basically going to be where we build our view packets, right? So the render here comes after the update. We could technically do this in the update if we really wanted to. But since it's part of sort of the rendering, I guess it kind of makes sense, to me at least, to do it here. We may wind up changing that in the future, but for right now, I'm going to go ahead and do it here. And so what we're doing is we are going through our views. We are creating an array using our linear allocator for those views. We are handling our Skybox, handling our world meshes, building our packets. So there's the world, there's the UI, there's the pick. And then once we've done all that, we'll go ahead and return true. And the application at that point will, let's see, where is it? So here we go. So we have the game's render routine here, and then it calls render frame, right? So it happens right before we call render frame, and then it goes into the back end and makes all the draw calls. So it makes sense to me to actually include all of that logic here. So one more thing that we have to do is we actually need the game on resize to actually do something now. And that is sort of what was in the event handler in the application.c. So we're going to take the width and the height out of that, and then we're going to scooch the UI text position of our test text to be towards the bottom of the screen. So this is an example of logic that we'd want to handle here. And finally, we are going to have our configure render views. So that we're defining this function that we forward declared at the top of the file. And basically what we're going to do here is we are going to create a new DArray for our config render views, all right? And we are going to basically take all of the configuration that we had before, and we are going to push into that array. So I'm going to paste it all at once because literally nothing has changed here. This is all just moved from the application C file. So we basically go through each one of the views, set up our render pass config, our attachments, and then push it to that array, okay? And then we literally do the same thing for each view, right? So it's literally the same thing. It's just we go through the configuration. Again, This probably should be read in by a file at some point, but we don't have that yet, so we're still going to stick with doing it here. All right, finally, since this is a Boolean, we do want to go ahead and return true on that. And I do believe that is everything that we need to do. So I'm going to go ahead and clean and build. And let's go ahead and run, and hopefully we didn't break anything. Okay, so it looks like our metrics are all working, our mouse position's working, our input works, loading works, so that looks good. Let's go ahead and test some resizing. So it looks like our resizing works. It scooches our text down here to the bottom. It looks like our object picking still is working as expected. Our debug modes are good to go. So yeah, we are good to go. That is going to do it for this video. So again, this was mostly just moving stuff around, but hopefully it gives you guys an idea of how we're going to sort of structure things going forward, because we want to keep customizations out of the engine, and we want to offload a lot of that responsibility to the application itself, so that the test bed or the editor, when we stand that up, can configure themselves the way that they need to be configured, and go from there. So anyway, that's going to do it for this video. Thank you guys so much for watching. If you haven't already, consider subscribing, toss me a thumbs up, leave me a comment. All those things help me out a great deal with the YouTube algorithm and helping me to get exposure for the channel. So I appreciate you guys so much. I'll see you next time.